Imagine you have been given an 8.5 by 11 sheet of paper, and without doing any research, you have been asked to make a paper airplane. How did it fly? Did it meet your expectations, or did it crash and burn? If you could start over, what would you change? Maybe it could bend the tips of the wings, add a penny or a paperclip to the nose for adding weight. How much better would your plane fly after only a few minutes of experimental phase? How many flights does it take to test the airplane? 1, 2, 5, 10? You have probably lost count. If you were given another sheet of paper, what would you do differently? Are you designing for speed, distances, stunts? This is where communicating with your end user becomes important. Rapid prototyping instructional design is much like this process of making a better paper airplane. Through experimentation, you achieve results that better address the objectives.
In the late 1980s, rapid prototyping was beginning to take place in the industrial fabrication sector. As a result, in 1990, Stephen D. Tripp and Barbara Bischelmeyer developed the rapid prototyping instructional design model. Industrial fabrication companies were wanting to find ways to reduce the development time and get their products to market faster and cheaper. Rapid prototyping instructional design also has a similar aim with this end goal of producing more effective instructional design that has a shorter development window and lower cost. The ideal conditions to apply this model include environments where time and money are limited. Since a linear model may not always provide the best solution, rapid prototyping should take a systemic approach to evaluate the complex environmental conditions.
In the rapid prototyping instructional model, the customer takes on multiple roles such as subject matter expert, end user, or purchaser of the product. Much like the ADDIE model, rapid prototyping still involves a front-end analysis, design, development, implementation, and evaluation. However, there is a greater emphasis on experimentation and research during several phases of the model. This model acts with several stages occurring in parallel. Once an appropriate front-end analysis has taken place, the construction, utilization, and deployment of the end product happen simultaneously. This allows rapid development where feedback can be gathered and modification can be made towards improving the final design.
In the rapid prototyping model, there is active participation between the client throughout the design and development, rather than only at the evaluation and assessment stages. The design and development often take place in the form of experimentation, improving upon previous designs. This model focuses on customer satisfaction, whether the end product is intended for use inside or outside of the organization. Therefore, this model is ideal for instructional situations with tight deadlines.
Since the end user is critical during development process, when executed properly, rapid prototyping modeling can assure customer satisfaction. The initial design may be used, modified, or even discarded through the design process. Ultimately, additional prototypes may be developed towards achieving client expectations.
Some of the advantages of rapid prototyping include discovering problems early in the design process and gaining insights from the end user regarding appearance and usability. This approach is attractive since it can reduce development and operational costs, improve communication, reduce development time, and produce a customized product that meets the client's demands.
This model relies on the experience of the instructional designer to manage efficiently the different steps in the implementation of rapid prototyping. Poor communication between the client and developers can generate instructional conflicts dooming this project. Rapid prototyping relies on the continued flow of resources such as money and people, and if there is a shortage, the project may not succeed. Furthermore, the model's philosophy emphasizing the solution of problems cannot underestimate the relevance of conducting a proper front-end analysis. If an instructional designer or customer commit too early to a specific design, other possibilities may be overlooked and never explored.
In summary, rapid prototyping instructional design is a model that encourages experimentation and close communication between the instructional designer and client. While the steps of the model largely reflect a modified ADDIE framework, the importance of experimentation and revision make it a unique approach to find better solutions. So, the next time you are faced with limitations in your time and budget, think about using rapid prototyping instructional design as a model to improve the success of your project.